Lesson 2.4, Task 1. Investigate intersections of lines and graphs of quadratic equations. Previously, you have solved linear systems which are formed by linear equations. Now you will work with linear quadratic systems, which are formed by a linear equation and a quadratic equation. Recall that the graphs of quadratic equations can be parabolas, or, as you have seen in previous courses, circles. Alright, a real-world example of a linear quadratic system is shown. The coverage area of a cell phone tower can be represented using a circle with the cell phone tower at the center. The line represents a road that passes through the area. The road intersects the edges of the cell phone tower coverage area at 2 points. So you can see the 2 points it intersects here and here. Alright, it says the graph shows a linear quadratic system composed of a parabola and a line, which is represented by the equation y equals 2. So you can see the line y equals 2 is here, and here is the parabola, and they intersect here at 1 point. How many points of intersection does this system have? That would be 1. And vertically translate the line up 3 units. How many points of intersection will the new system have? Okay, so if I move this line just up 1, 2, 3, the line would be a horizontal line through y equals 5, and that would have a point here and here. So it would have 2 points of intersection. Alright, it says use a sketch to justify your answer. I'm going to just look at the one they have provided, which is here's the parabola and here is the line. You can see that it intersects here and here. Alright, it says vertically translate the original line, y equals 2, down by 4 units. How many points of intersection do the parabola and this translated line have? Alright, so the original line was at 2, and it says translate it down. So we're going to have a line down here that does not intersect with the parabola at all. So if you translate it down 4 units, you will have 0 points of intersection. Alright, look at the graph. Here's the original parabola. The original line went through here and it said move it down 4 units. 1, 2, 3, 4. You can see the new line is here and they do not intersect. So 0 points of intersection. What do you recall about a line that is tangent to a circle? How many solutions are possible in a system where a line is tangent to a circle? Alright, so remember a tangent line creates a 90-degree angle with that circle. So it creates 1 point of intersection. And there is one solution possible in the system where a line is tangent to a circle. This is because there is only 1 point of intersection. So a line that is tangent to a circle intersects the circle at exactly 1 point. There is one solution possible in a system where a line is tangent to a circle. This is because there is only 1 point of intersection. Alright, think about how many ways the graph of a line function can intersect the graph of a circle. Alright, so if the line is outside the circle, there would be no solutions. If it's tangent to the circle, it would be 1 solution. And if it goes through the circle and intersects on each side of the circle, there would be 2 solutions. So it could be no solution, 1 solution, or 2 solutions. Alright, this is a visual image of no solutions. The line does not intersect the circle. Here's one where it has a tangent line, and here's one of 2 solutions. If you're not sure what a tangent line is, just for a refresher, look up the definition of tangent line and you'll see what that is. Alright, so how does the possible number of solutions for a system with a linear equation and a circle compare to a system with a linear equation and a parabola? Alright, so it would be the same because you could have no solution, you could have 1 solution, or you could have 2 solutions. So if the line doesn't intersect the parabola, that means no solution. If it's tangent to the parabola or it intersects at the vertex, it would be one solution. Or if it crosses through the parabola, it would cross at 2 points. So there are the same number of possible solutions for both kinds. There are more possible solutions. There are more possible solutions. So I'm going to say there are the same number of solutions for a line in a circle and a line in a parabola. All right, is it possible for a linear quadratic system to have infinitely many solutions? No. So, no, there cannot be infinitely many solutions because the graph of a quadratic equation is a parabola, and any line that intersects a parabola can intersect at most 2 points. All right, that's all for task 1. If you have questions, please let me know. Lesson 2.4, task 2. Solve a linear quadratic system by graphing. In an earlier course, you solved systems of 2 linear equations by graphing. You can use the same strategy to find solutions to a system of a linear equation and a quadratic equation. Solve the system of equations by graphing. 3x plus 4y equals 25 and x squared plus y squared equals 25. Rewrite the linear equation to be in slope-intercept form. All right, so if you take this equation here and rewrite it in slope-intercept form, that's basically saying we're solving it for y. So you would subtract 3x and then divide everything by 4 to get this equation here. Then graph both equations on the same coordinate plane using a graphing calculator. All right, so this is the equation of the circle here, and this is the line. And you can see that they intersect, it looks like, at 3, 4. So it says how many solutions will the system have? They will have one solution because there is 1 point of intersection. All right, and because that line is tangent, we know that they intersect at exactly 1 point. All right, find the solution to identify the point of intersection, 3, 4. If you look at the graph, it's pretty easy to see that that is the point of intersection. Okay? All right, it says check the solution by substituting values into the equation. So the point 3, 4 will be substituted into both the linear equation and check, and to the circle equation and check. And you can see that when they substituted 3, 4 into both equations, it worked. Why must the solution satisfy both equations? The solution must be a point that lies on the line and the circle. If the solution satisfies only one, then it is not. If it satisfied only one of the 2 equations, then it is not a solution of the system because it is on only one of the graphs. So if it's going to be a solution of the system, it has to be a point on both equations or both lines, or the circle and a line in this case. All right, so it says the substituted values, x equals 3 and y equals 4, satisfies both equations in the system, so the solution 3, 4 is confirmed or correct. All right, that's all for task 2. If you have any questions, let me know.